Greetings, Cinemaniacs! It's your boy, Griswold, and today we're going to be learning how to make this looping, cloner-based particle system animation using MoGraph effectors and a little bit of Expresso. Animations like these are great when you need to create a lot of content with short render times. They can be filmed from a lot of different angles without revealing the fact that they're actually very short loops. Alright, let's take it from the tippy. To get the basics of our looping motion, we're going to want to work with a single object in isolation. Next, we're going to make copies of this object by using a MoGraph cloner, and if we Alt-select cloner from the MoGraph menu with our capsule selected, we'll automatically nest our capsule inside the cloner. We can increase the spacing in between these clones by adjusting the Y spacing property. And in order to make our animation loop, we need our cloner to move 220 centimeters, or our Y spacing property, over the course of the animation. So to start, we'll do this with keyframes. I'll keyframe the Y position to be 0 at the first frame, and at the last frame, I'll dial in a value of 220 centimeters, which is the spacing value for our cloner. If I play this back, we'll start to see some animation, but we'll notice a few problems. For one, the cloner is moving up instead of down, and to change that I can simply set this value to be negative 220 at the last frame. Next, we'll notice that the animation is slowing down and speeding up over the course of the timeline, and that's because by default, Cinema4D is going to be using spline interpolation for our keyframes. We can change this by selecting the keyframe and going to interpolation linear, which will make the velocity of our animation consistent throughout. Now, we can also clearly see the point at which this cloner repeats, and we can hide the seam by simply dialing up the number of clones in our cloner. If we move the camera up a bit to hide that bottommost point, we'll have an animation that appears infinitely long, but is actually only 90 frames. Great. Now, what if we want to adjust the spacing value of our cloner? Obviously, if we change the distance between clones, the keyframed value that we added earlier will no longer be correct and will break our seamless loop. We can add a bit of Expresso to make it so there's a relationship between this Y spacing value, the time of our animation, and the Y position property of our cloner. So to start, let's kill these keyframes by right-clicking on the Y property and going to Animation Delete Track. And then we're going to add an Expresso tag to our cloner by right-clicking, going to Cinema4D tags, and selecting Expresso. This will give us a blank Expresso patch, and our first step will be to add a node for our cloner. We can do this quickly by dragging the cloner into the Expresso patch, and we can expose ports on our Expresso node by selecting any attribute and dragging it onto the right side of our Expresso node. In this case, I'm bringing over the Y spacing property. Next, we'll need to add another node for our cloner, as we want to control the input value of our cloner with one of its outputs, but we can't connect nodes to themselves like this. So, much in the same way, I can expose an input port for our cloner by dragging this Y position property to the left side of the node. Next, we'll need to access the current position of the animation playhead. We can do that with an Expresso node called time, which by default will expose one port called time, and that reports the current animation position in seconds. We can expose another property from this time node called end, and that will give us the total duration of our animation timeline. Next, we're going to need to do a little bit of math, and we can do that with the aptly named Expresso node math under the calculate menu. And this can perform a number of mathematical operations with which I'm sure you are familiar. And what we're going to need to do first is divide the current time of our animation by the total duration of our animation. So we'll set the math node to divide, pipe time into the first input, and end into the second input. Now we can see the result of any Expresso node by using a result node. And if I connect the output of our division node and scrub the timeline, we'll see that the result value is changing from 0 to 1, where it is 1 at the end of the animation and 0 at the beginning. So, if we were to multiply this value by our cloner's Y spacing and pass that into the position, we'd basically be recreating the animation we had earlier using keyframes. I'll drop down one more math node and set it to multiply, pipe the output of our division into one of the inputs, and our cloner's Y spacing property into another, and finally connect that to our cloner's Y position. If we play our animation, we'll notice we have movement much in the same way we did before, but with some of the original problems. So to invert that direction, I can click on the blue region in our math node and expose another input port, and we'll get a constant value here. We'll set that to -1 to reverse the motion, and now the clones are moving down. So the benefit of this is now if we're to go back to our cloner's Y spacing value and adjust the distance in between clones, the animation will speed up or slow down accordingly depending on how much ground it has to cover. Better yet, we can change the duration of our animation and still maintain the seamless loop. Let's set it back to 90 frames or 3 seconds. And next we're going to want to add a few more capsules to the scene so that we can fill up the entire viewport. I'm going to select our capsule and add another MoGraph cloner inside our main cloner. I'm going to set this to grid array mode so it fills up a volume. We'll need to shrink our capsules a bit as they are starting to overlap. And let's add a bit more spacing on each axis, and probably a few more clones as well. Let's go with 5 and 5 here. I'm going to zoom in a bit so these start to meet the extremities of our image. And next we're going to want to add some randomness to break up the regularity of this pattern. If we select our inner cloner and go to MoGraph Effector Random, we'll automatically add some jitter to the position value of these clones. We can also randomize the rotation for a bit more of a festive look. And last, let's jitter the scale uniformly on each axis to give them some contrast in size. There we have our looping, cloner-based particle system. But for our last step, let's add a bit of rotation to these clones for a little more detail. And we'll select our cloner again, but this time add a MoGraph time effector, and add some rotation to the p-axis to see what we get. Now they are indeed spinning, but this unit for the time effector is specified in degrees per second, and we need our animation to complete 1 full revolution or 360 degrees over the course of our animation. If we set this to 360, we will get a seamless loop, but they're spinning quite a bit, and that's because our animation is 3 seconds long, so we can divide 360 by 3 to get 120 degrees, which will complete a full revolution over the duration of our timeline. Now again, if we change the length of our animation, we're going to break this rotation value, but I'll let you write your own Expresso tag that changes this rotation value based on the duration of your timeline. So that about does it for today's particle system tutorial. For now, I'll leave you with this render that I made in Octane and bid you adieu. Thanks for watching, and keep on looping.